Hello students, how are you all? And in this lecture we are going to discuss exercise number 3.2 9 to 15 problems. So that we are going to complete this chapter. Okay? So before going to our class, let's close our eyes and let's start prayer. God, kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. Alright, let's move on to the exercise number 3.2, problem number 9. Alright, let's move on to this. If A is equal to 1 3 by 3 matrix and the identity I is the identity matrix of third order, means that is also 3 by 3 matrix, then prove that A square minus 3A plus 9A is equal to minus 6 1 2 5 4 4 2 8 minus 3. First take your LHS and solve it. So your LHS is A square minus 3A plus 9I. So now A square means A into A. That means 1 minus 2, 3, 2, 3 minus 1, minus 3, 1, 2. Okay? Into again that A only 1 minus 2, 3, 2, 3 minus 1, minus 3, 1, 2. Minus 3 into A. 3 into again A is 1 minus 2, 3, 2, 3 minus 1, minus 3, 1, 2. Next, plus 9I. Plus 9 into what is I? So 3 by 3 order means 1, 1, 1, 0, 0, 0, 0, 0, 0. Except that principal diagonal, remaining all should be the 0. So this is about just substitution. After substitution, just normal multiplication, then you are going to get. So you already know that first row with first column you get as first element. So now I am writing directly this one. 1 ones are 1 plus minus 2 into 2 is nothing but you get as minus 4. 3 into minus 3 minus 9. Now 1 into minus 2, that is for second element. Okay, first row second column you get as second element. 1 into minus 2 minus 2 minus 2 into 3 minus 6. 3 into 1 plus 3. Next 1 into 3 3, then minus 2 into minus 1 plus 2, 3 into 2 plus 6. Same method remaining all also. Second row now. 2 into 1, 2, 3 into 2, 6, minus 1 into minus 3 plus 3. Now 2 into minus 2, minus 4, 3 into 3 plus 9, minus 1 into 1, minus 1. Next, 2 into 3, 6, 3 into minus 1, minus 3, minus 1 into 2, minus 2. Same method next. Minus 3 into 1, minus 3, 1 into 2, plus 2, 2 into minus 3, minus 6, and then next minus 3 into 2, minus 6, minus plus 3, 2s are 6, 1 into 3, that is nothing but 3, 2 into 1, that is nothing but 2. So after that next, minus 3 into 3, minus 9, and 1 into minus 1 is nothing but minus 1, 2 into 2 is nothing but plus 4. And same method here, just multiply with the 3. 3 ones are 3, 3 twos are minus 6, here minus 2, that's what minus 3. 3 threes are 9, 3 twos are 6, 3 threes are 9, 3 minus 1s are minus 3. 3 into minus 3 is nothing but minus 9, 3 into 1, 3, 3 twos are 6. Same method, now identity element, 9 ones are 9, 0, 0, 0, 9, 0, 0, 0, 9. Just normal multiplication. Normal multiplication. And now here what you get. And so I hope so you are finding each and every point. Now let's move on to the simplification. So when you simplify minus 9 minus 4, it is nothing but minus 13. Minus 13 plus 1 minus 12 you get. Then minus 6 plus 3 minus 3. Minus 3 minus 2 minus 5. And next 6 plus 3 9. 9 plus 2 11. So I am writing this all. Then 6 plus 3, 9, 9 plus 2 is 11. 9 minus 4, 5, 5 minus 1 is nothing but 4. 6 minus 3 is nothing but 3, 3 minus 2 is nothing but 1. Minus 3 minus 6 minus 9, minus 9 plus 2 is nothing but minus 7. 6 plus 3, 9, 9 plus 2, 11. Minus 9 minus 1 minus 10, minus 10 plus 4 is nothing but minus 6. Now remaining whichever is there. So minus 3 minus 6, 9, 6, 9 minus 3, minus 9, 3, 6. And these both just add. Why to do in this way first? Okay, let me complete this part first and then we'll go for that. That will be the better. So right here plus 9 0 0 0 9 0 0 0 9. Okay, so up to this step I hope so you all understood. Let's move on to the next step now. So for that I'll rub the first two parts and I'll complete that. Okay. All right, next this I'll write here. You just concentrate. Minus 12 minus 3 minus 15. Next minus 5 minus of minus 6 means plus 6. Minus 5 plus 6 is nothing but how much you are going to get? 1. 11 minus 9. 11 minus 9 means what you get? Minus 2. Sorry, 11 minus 9, 2. Next, 11 minus 6 is nothing but 5. 4 minus 9 is nothing but minus 5. Next, 1 minus of minus 3 is nothing but plus 3. So 1 plus 3 is nothing but 4. Minus 7 minus of minus 9 means plus 9. So 9 minus 7 is nothing but 2. 11 minus 3 is nothing but 11 minus 3 is nothing but 8. Right? Next, minus 6 minus 6 minus 12. This plus 9 0 0 0 9 0 0 0 9. So then when you add these two also, what you are going to get? Because I need to get this answer. Minus 15 plus 9. Minus 15 plus 9 is nothing but minus 6. 1 plus 0 is nothing but 1. 2 plus 0 is nothing but 2. Another one it is 5 plus 0 is nothing but 5. Minus 5 plus 9 is nothing but 4. 4 plus 0 is nothing but 4. 2 plus 0 is nothing but 2. 8 plus 0 is nothing but 8. Minus 12 plus 9 is nothing but minus 3. So this is your, that is equal to your RHS. Once you check RHS correct on minus 6, 1, 2, minus 6, 1, 2, 5, 4, 4, 5, 4, 4, 2, 8, minus 3. So you got this. So LHS at last, therefore LHS is equal to RHS, hence proved. Understood now? I hope so you all understood this 9th problem. Let's move on to the 10th problem now. Alright, let's move on to the 10th problem. If 1 by 3 matrix and then 3 by 3 matrix, 3 by 1 matrix, these are multiplied equal to 0 matrix, that is 0 happened, solve for A. So you need to find A value. It is very easy, like your 8th problem method. So let me solve how it is possible. So here check first number of columns of first matrix is equal to the number of rows of second matrix, so that we can multiply. So now first row multiplied with first column, then second column, then your third column, then it is possible to get your answer. So I'm writing here directly here your solution. A into 2, 2A, 4 into 1, 4, 1 into 0, 0, so that no need to take. A into 1, A, 4 into 0, 0, we don't want to take. 1 into 2, 2, that is plus 2. Next, A into 2, 2A, and after that what we can do here? So we have first one multiplied with this, you get as first element, then second element, then third element it is. A into 2, 2A, 4 into 2, 8, 1 into minus 4. So you got here elements, and here it is A4 1. It is 3 by 1 matrix, it is 1 by 3 matrix. So again we can able to multiply. This is equal to O matrix or 0 I will keep now, because whenever here only single matrix you are getting, so that 0 I written. Okay. So now here what we can do, again same method, but first let me simplify. 2a plus 4, a plus 2, 2a, 8 minus 4 is nothing but plus 4, 2a plus 4 again. Now A4 1 is equal to 0. Then again same method. First row, first column, only one single element you are going to. 2a plus 4 into a plus 4 into a plus 2 plus 1 into 2a plus 4 is equal to 0. Then simple. 2a into a 2a square plus 4 into a 4a plus 4 into a 4a plus 4 2s are 8 plus 1 into 2a plus 4 2a plus 4, that is equal to 0. Now 2a square as it is plus 4a plus 4a 8a 8a plus 2a 10a, so plus 10a plus 8 plus 4 is nothing but 12, that is equal to 0. In all 2 common, then a square plus 5a plus 6, that is 0. 2 here multiplying, go to that side division, so anything divided 2, so it is 0 upon 2 is nothing but 0. So now what you got here at last, you got as a square plus 5a plus 6 is equal to 0. Now what I need to do, just to split the middle term, that is a square plus 3a plus 2a plus 6 is equal to 0. A common, a plus 3 plus 2 common, a plus 3, that is equal to 0. Then a plus 3 common, then a plus 2 is equal to 0. A plus 3 is equal to 0. A plus 2 is equal to 0. A is equal to minus 3. A is equal to minus 2. So you can write as at last, therefore a is equal to minus 3 comma minus 2. So now at last you found a value as minus 2 comma minus 3 or minus 3 comma minus 2. This is about your problem number 10. Let's move on to the problem number 11. Alright, let's move on to the 11th. If a is equal to 1 minus 1, 2 minus 1, 2 by 2 matrix, b is equal to a1, b minus 1, and a plus b whole square is equal to a square plus b square, then find the values of a and b. So first find a plus b whole square, then find a square plus b square. So first solution, a plus b, first find a plus b. So a plus b whole square means first find a plus b. So what you get? So directly I am writing 1 plus a minus 1 plus 1 is nothing but 0. 2 plus b minus 1 minus 1, that is nothing but minus 2. Okay, next a plus b whole square means multiply twice. 1 plus a 0, 2 plus b minus 2, again 1 plus a 0, 2 plus b minus 2, then multiply first row, first column for first element. So when you do that, 1 plus a into 1 plus a, 1 plus a whole square plus 0 into any number 0, so that no need to write. Now 1 plus a into 0, 0, 0 into minus 2 is also nothing but 0, so that second element should be 0. Next, 2 plus b into 1 plus a, so right here 2 plus b into 1 plus a. Next, minus 2 into 2 plus b, so right here plus minus 2 into 2 plus b. Okay, next, last one, 2 plus b into 0, 0, minus 2 into minus 2, minus into minus, plus 2 2s are 4. You got this? Just simplify this part. So when you simplify, what you are going to get, let me check now. So 1 plus a whole square means what we can write? 1 plus 2a plus a square, and here it is 0. Now 2 into 1, this simplify here and then write only answer. 2 plus b into 1 plus a plus minus 2 into 2 plus b. Just simplify. 2 into 1 2 plus 2 into a 2a plus b once a b plus a into b ab. Then here minus 2 into 2 minus 4 minus 2 into b minus 2b. So now let me check what is simplification here. 2a plus b minus 2b is nothing but minus b. So this and this completed and this also completed. And then 2 minus 4 is nothing but, that is nothing but, we can write it as minus 2 and then plus ab. So just write only that part. 2a minus b plus 2 plus ab. And next part is here 4. Okay. So a plus b whole square we found. This gives us equation number 1. So now we are going to that a square plus b square 1. So let me check that is how it is possible to solve that part. Okay. And so now a square plus b square also will solve here itself so that you can understand. So now you can observe carefully so that you can understand, otherwise it is not possible to understand. Let's check now here. It is first a square plus b square, that means a into a and b into b. So a into a means 1 minus 1 2 minus 1, and again 1 minus 1 2 minus 1, plus b into b means a1 b minus 1, again here a1 b minus 1. So let me multiply and then check your answers. First row, first column, 1 ones are 1, minus 2 into 2 minus 2, minus 1 into 2 minus 2, 1 into minus 1 minus 1, minus 1 into minus 1 is nothing but plus 1. Now 2 into 1 2, minus 1 into 2 minus 2, 2 into minus 1 minus 2, minus 1 into minus 1 plus 1. So now you got as a square plus next one here, a into a square plus 1 into b, a into 1 a, 1 into minus 1 minus 1. Next b into ab. Now minus 1 into b is nothing but minus b, b into 1 b, minus 1 into minus 1 plus 1. See, easily we need to check and we don't want to go for difficult procedures. Okay. So now 1 into minus 1 minus 1, minus 1 plus 1 0, 2 minus 2 0, minus 2 plus 1 minus 1, that is plus. And so here we can write plus a square plus b, a minus 1, ab minus b, b plus 1. So what I can do with this, you can just observe carefully so that you can understand, otherwise it's not possible to understand. Then when you add a square plus b minus 1, so write a square plus b minus 1, 0 plus anything, that only, so that a minus 1, 0 plus ab minus b, you can write ab minus b, minus 1, and here b plus 1 minus 1 is nothing but 0, so only b you are going to get. So now up to here you got answer. Now comparing corresponding elements, this is equation number 2. So according to your question, 1 is equal to 2. Then we can solve. So first 2 steps I'll drop and I'll write. Right, according to your question, 1 is equal to 2. So I can write given 1 is equal to 2. That means 1 plus 2a plus a square 0. 2a minus b plus 2 plus ab 4, that is equal to a square plus b minus 1, a minus 1, ab minus b, b. So use comparing. So when I am writing this CC, you are not writing in your examination time. So that's what I am writing now, full form. Comparing corresponding elements. When you compare these corresponding elements, what will happen? So this easy way you need to find out. You are finding easily a and b values. So first a minus 1 is equal to 0, b is equal to 4. Minus 1 go to that side, plus 1. So at last, therefore, a is equal to 1, b is equal to 4. This much simple. So we don't want to take that the difficult one, we need to take easiest one, then we can complete it. So that is about your problem number 11. Let's move on to the problem number 12. Alright, let's move on to the problem number 12. If a is equal to 0 minus tan x upon 2 tan x upon 2 0 and I is 2 by 2 matrix, prove that I plus a is equal to I minus a, that is cos x into minus sin x cos x. So first let me take the LHS and find. Before going to this, remember what is cos x, what is sin x formulas. Then you are able to solve this. So now let me go for this solution. The first one, it is I plus a. Anyhow, I plus a I will find later. And first I am going to, okay, let me solve this I plus a first. So what is I here? 2 by 2 matrix means 1 0 0 1 plus what is your a here? 0 minus tan x upon 2 tan x upon 2 and another one it is 0. So then when you add this 1 plus 0 1, 0 minus tan x upon 2 means minus tan x upon 2, 0 plus tan x upon 2 means tan x upon 2, 1 plus 0 is nothing but 1. This is your equation number 1. And now we need to go for problem this RHS part, and this is your LHS part. And now RHS also let me solve, and then you can understand how to solve this. Okay, so let's move on to that RHS. Before going to that RHS, you just remember these formulas. Cos x is equal to 1 minus tan square x upon 2 upon 1 plus tan square x upon 2, sin x 2 tan x upon 2 upon 1 plus tan square x upon 2. This you have to remember, then everything becomes easy for you. So let me solve here so that you can understand. So now I minus a, so your RHS is equal to I minus a into cos x. Cos x means what I said for you. So you remember that is 1 minus tan square x upon 2 upon 1 plus tan square x upon 2. Next, minus sin x means what can I write for minus sin x? So minus sin x formula is 2 tan x upon 2, that is upon 1 plus tan square x upon 2. Next, what is again sin x? So same thing, only 2 tan x upon 2 upon 1 plus tan square x upon 2. Next, cos x means again 1 minus tan square x upon 2 upon 1 plus tan square x upon 2. You may ask, sir, why sir you are written in tan form? Because our answer need to come in the tan form, because of that reason. So now I minus a. So I is nothing but what? So directly can I write that? So I minus a means wherever here I plus a place, wherever plus came, that place we need to write as a minus. So simply here if you keep minus 1 minus 0 1, another one 0 minus of tan x upon 2, that is plus tan x upon 2. Next one here 0 minus tan x upon 2, so that is minus tan x upon 2. And then next 1 minus 0 is nothing but 1. So as it is you are going to get, but only the small change will be plus tan x upon 2 becomes as, sorry, minus 1 becomes as plus and plus becomes as minus. Only these two parts only will change. And next one, as it is this part, write down what is that? 1 plus tan square x upon 2, that is upon 1 minus tan square x upon 2 minus 2 tan x upon 2 upon 1 plus tan square x upon 2. And then after that Again here 2 tan x upon 2, that is 1 plus tan square x upon 2. Again here 1 minus tan square x upon 2, that is 1 plus tan square x upon 2. So after that just you need to multiply. So when you multiply, what you are going to get, that I'll write again here this part. I hope so you written up to this part. If you are not written, pause it and then complete that part. Okay. Now again this multiplication, how it is. So first row and then first column and then first row second column. So now 1 into this means you will get that full. So 1 into 1 plus tan square x upon 2 upon 1 minus tan square x upon 2 means that only you can write. So that means 1 plus tan square x upon 2 upon, sorry, this is what, 1 minus tan square x upon 2 upon 1 plus tan square x upon 2. Okay, so here it is 1 minus tan square x upon 2, 1 plus tan square x upon 2. First one, tan x upon 2 into this. So then 2 into tan x upon 2 into tan x upon 2, 2 tan square x upon 2. So you can write plus 2 tan square x upon 2, that is upon 1 plus tan square x upon 2. So now first one completed, then second one. 1 into this means you get as it is, that means minus 2 tan x upon 2, 1 plus tan square x upon 2. Next, tan x upon 2 into this means, so what you get here, it is tan x upon 2 into this means tan x upon 2 ones are tan x upon 2. So right here plus tan x upon 2. Next, plus into minus, minus tan square x upon 2 into tan x upon 2 means tan cube x upon 2. So right here minus tan cube x upon 2, that is upon 1 plus tan square x upon 2. So only this first and second element completed. Now second means your second one and first. So when you multiply with this minus tan x into this minus tan x into 1 minus tan x upon 2. Next minus into minus plus tan x upon 2 into tan square x upon 2 means plus tan cube x upon 2 upon 1 plus tan square x upon 2. Next, 1 into this means as it is, that you can write plus 2 tan x upon 2 upon 1 plus tan square x upon 2. Same method next one. Minus tan x upon 2 minus 2 tan x upon 2. Minus into minus plus 2 tan square x upon 2. Right. So upon 1 plus tan square x upon 2 plus, now 1 into this means as it is, right, plus 1 minus tan square x upon 2, 1 plus tan square x upon 2. So now I'll rub this part and remaining I can write so that you can understand clearly this part, otherwise it is very difficult to understand. Calculation, if you are not understood, that is pause it twice and thrice and then understand it. It is very simple calculation. Okay, so that is about your matrix. So this matrix is your I minus A into, that is means RHS, this part. Okay, this is your RHS. Now this is equal to, now both places what we need to take, LCM take, that is 1 plus tan square x upon 2 and 1 minus tan square x upon 2 plus 2 tan square x upon 2. That means 2 tan square x upon 2 minus tan square upon 2 means what you get, 1 plus tan square x upon 2. Okay, 2 tan square x upon 2 minus tan square x upon 2 means tan square x upon 2. Same method now here also, let me check. So here 1 plus tan square x upon 2. Now in this place you just sorry, this all we need to consider. So now here minus 2 tan x upon 2 and tan x upon 2 means what you get? Minus tan x upon 2. So now here you get as minus tan x upon 2 minus tan cube x upon 2. Right? Next. It is not tan 3x, it is tan cube x upon 2. Next one after that. Here also same method. Now LCM is 1 plus tan square x upon 2. And here it is tan cube x upon 2 first. Next. Minus tan x upon 2 plus 2 tan x upon 2 means plus tan x upon 2. Okay. Next. Here it is again 1 minus tan square. See here, 2 tan square x upon 2 minus tan square x upon 2 plus tan square x upon 2. So plus 1 plus tan square x upon 2 upon 1 plus tan square x upon 2. Now first in this, any simplification possible, check. These both is same, cancel, get as 1. Again these both are same, cancel, get as 1. So remaining part, again I'll rub this part and again I'm going to write so that you can understand clearly, otherwise it is very difficult for you. Okay. Okay, next what we can do here. So here we can write here this as first 1 is there, and in both minus tan x upon 2 we can common. So write here minus tan x upon 2 common. When you common it, here this is 1. And if I want minus here, plus will be tan square x upon 2. And here down also 1 plus tan square x upon 2 is there. Now, next here tan x upon 2 common. What do you get? 1 plus tan square x upon 2. So 1 plus tan square x upon 2. That is again here 1 plus tan square x upon 2. Here what is there? 1. Now check. This and this cancel once. Here also once. So at last what you get here? This is equal to 1 minus tan x upon 2 once. Minus tan x upon 2. Tan x upon 2 once. Tan x upon 2. Here it is 1 is there. 1. This gives us equation number 2. Now from 1 check, from 1 and 2 what you observe? 1 is what? 1 minus tan x upon 2, tan x upon 2, 1. And what about 2? 1 minus tan x upon 2, tan x upon 2, 1. That means what you understood. So your LHS is equal to your RHS. So now hence it is proved. So I'll write this part here so that I'll complete this part here itself. So now here from 1 and 2, LHS is equal to RHS, hence it is proved. Okay. So here LHS is equal to RHS, hence it is proved. So that is about your problem number 12. And these kind of problems are very important for your examination point of view. If you have any doubts, you can comment on YouTube section so that I can help you all again. Okay. So that is about 12th problem. Let's move on to the 13th. Now let's move on to the next problem. It is if A given and I also given, then find the value of K where A square is equal to 8A plus Ki. 8A plus Ki. So how can we solve this? Just however it is like that only we have to find. We don't want to do anything in this. So solution. So given here A square is equal to 8A plus Ki. Now A square means 1 0 minus 1 7. Here also 1 0 minus 1 7. 8 into A, so 8 into A is 1 0 minus 1 7 plus K into I is nothing but 1 0 0 1. So just multiply first row, first column for first element, 1 into 1, 1, 0 into any number, 0, so I don't want to write 1 into 0, 0, 0 into 7, 0, so that's 0. Minus 1 into 1, second row, first column for the first first element of second row. Minus 1 into 1, minus 1. 7 into minus 1, minus 7. Next, minus 1 into 0, 0. 7 sevens are 49. Cleared? So that is equal to your 8. 8 zeros are 0, minus 8. I think, so next 8 sevens are 56. Plus k ones are k, 0, 0, k ones are k. Now, again this part, simplify. 1, 0, minus 8, 49. That is equal to, here simplify, 8 plus k. Next, 0 plus 0, 0. Minus 8 plus 0, minus 8. 56 plus k. Very simple, no need to think about this anything. So just write here comparing corresponding elements. Comparing corresponding elements. So you need to do just compare the corresponding elements, then you get the value of k. Okay. So any one element it is enough, no need to go for all the elements. So now first let me go for this first one with the first one. That is enough. You can use this or this element, you get your value of k. I use only the first one, that is 8 plus k. So 8 plus k is equal to 1. Okay. So now plus 8, go to that side, minus 8. So k is equal to 1 minus 8. K is equal to minus 7. So therefore k is equal to minus 7. If you want to verify, then do this part also. Here plus 56, go to that side, minus 56. Minus 56 plus 49 means again you get as minus 7. So therefore k value, what is that? Minus 7. In this way you have to find out, and this is very important for 2-mark question. So that is about your problem number 13. Let's move on to the problem number 14. Let's move on to your 14th problem. They given here if 1, 0, 2 minus 1, minus 3, 4, that is 3 by 2 matrix multiplied with A, so that you get result as this. Then find the A matrix. Alright, let's move on to the 14th problem. If 1, 0, 2 minus 1, minus 3, 4, 3 by 2 matrix into A is equal to this 3 by 3 matrix, then find the A matrix. So here first, what is your A matrix order, so that we can multiply both and we get 3 by 3 matrix. So it should be always here, see two columns are there, so that here must be 2 rows and then 3 columns, then only you get as 3 by 3 matrix. So because of that, therefore according to question, A order should be 2 by 3. If it is 2 by 3, what we need to do? If it is 2 by 3, then just I'll write here general form, then we can solve. So now first here what is given, that part I am writing directly. So I need to find A matrix. 1, 0, 2 minus 1, minus 3 and 4. A we can write it as 2 rows and 3 columns. So A11, A12, A13 and then A21, A22, A23. So now it is 2 by 3 matrix. So that is equal to 1 minus 4, 3, minus 2, minus 10, 6, 13, 20, minus 9. Now, just multiply first row, first column for first one, first row, second column for second one, in that way. So 1 into A11, A11, 0 into A21, 0. So no need to write that part. Next one. Okay, anyhow I'll write that 0. So 1 into A12, A12, 0 into anything, that is 0. Next 1 into A13 plus 0. So now first column, second column, third column multiplied. So now next again second row, 2 into A11, 2A11 minus A21. Next 2A12 minus A22. Next 2A13 minus A23. Next same method, another one. Here it is 2A13, 2A13. Okay. Next minus 3A11, 4A21 minus 3A12 plus 4A22. Next minus 3A13 plus 4A23. So multiplication completed. So that is equal to 1 minus 4, 3 minus 2 minus 10, 6, 13, 20 minus 9. Now comparing corresponding elements. Comparing corresponding elements. So when you compare corresponding elements, A11 plus 0 is equal to 1. That means, so here I can write for you, A11 is equal to 1, A11 is equal to 1, A12 is equal to minus 4, next A13 is equal to 3, A13 is equal to 3. Now we need to find remaining, so by using this, so first one 2A11 minus A21 is equal to minus 2. Then 2 into A11 is 1 minus A21 is equal to minus 2. 2 minus A21 is equal to minus 2. Minus 2A1 go to that side, plus 2A1, minus 2 comes to here plus 2. So 2 plus 2 is equal to A21. So A21 is equal to 4. Same method, next one. 2A12 minus A22. So here 2A12 minus A22 is equal to minus 10. So now 2 into A12 is nothing but minus 4 minus A22 is equal to minus 10. Now 2 into minus 4 minus 8 minus A22 is equal to minus 10. Now this end here, so minus 8 minus 10 becomes as plus 10, that is equal to A22. So A22 is equal to 10 minus 8 is nothing but 2. Same method. Next one, 2A13 minus A23 is equal to 6. Now 2 into A13 is nothing but 3 minus A23 is equal to 6. 6 minus A23 is equal to 6. 6 minus 6 is equal to A23 and 0 is equal to A23. So now last one only we have to find out. Here check now. A11, A12, A13, A21, A22, A23 find, and I think that is only, we found all the elements. And let me write our required matrix now. So where can I write? So I'll drop this part and I'll write our required matrix here. Okay. So I'm writing here for answer. So your required matrix, so is equal to, write that one first. A11 is 1, A12 is minus 4, next one is 3, next A21 is 4, A22 is 2, A23 is nothing but 0. So your required matrix is 1, minus 4, 3, 4, 2, 0. So this is about your required matrix. 1, minus 4, 3 and 4, 2, 0. So Like this you need to find out when they are not when they are given in this form. So that is about 14. Let's move on to the last problem of this exercise and this chapter also. Alright, let's move on to the last problem. If A is equal to cos alpha sin alpha minus sin alpha cos alpha, then prove that a power n is equal to cos n alpha sin n alpha minus sin n alpha cos n alpha. So here it is just like a power 1, and here 1 alpha sin 1 alpha so minus sin 1 alpha cos 1 alpha. So now I need to find what a power n I need to prove. For that solution, very simple here. A already you know, a square find first. So a square means a into a. That means cos alpha sin alpha minus sin alpha cos alpha into again cos alpha sin alpha minus sin alpha cos alpha. This multiply first row with first column. So when you multiply cos alpha into cos alpha, cos square alpha, sin alpha into minus sin alpha minus sin square alpha. Next, cos alpha into sin alpha. So you can write sin alpha cos alpha plus next sin alpha into cos alpha. You can write cos alpha sin alpha. Next, so however it is no problem by this. So if you want to write this also, you can write it as sin alpha cos alpha only. That becomes it is good also. So I'll write sin alpha cos alpha. Next, minus sin alpha cos alpha. So right here cos alpha minus symbol sin alpha. Next, cos alpha minus, so again minus cos alpha sin alpha. Next, minus sin alpha into sin alpha minus sin square alpha, cos alpha into cos alpha plus cos square alpha. You already know this formula, that is cos 2 theta is equal to cos square theta minus sin square theta. Another one, sin 2 theta is equal to 2 sin theta cos theta. This remember. Now see, cos square alpha minus sin square alpha means cos 2 alpha according to this formula. Now sin alpha cos alpha sin alpha cos alpha means 2 sin alpha cos alpha. That means it's nothing but sin 2 alpha. Directly I am writing. Okay? By using this formula. Next, here minus common. Then that time sin alpha cos alpha sin alpha cos alpha. How many times? 2 times. So 2 sin alpha cos alpha is nothing but sin 2 alpha. So you can write sin 2 alpha. Next, cos squared alpha minus sin square alpha. Again it is same method, cos 2 alpha. So a square you got this. Now a cube we will find. A cube is equal to a square into a. A square means this, it is cos 2 alpha sin 2 alpha minus sin 2 alpha cos 2 alpha. That is multiplied with your a, that is cos alpha sin alpha minus sin alpha cos alpha. Just multiply it. What you are going to get, just I am going to write in this place. So what you will get now from this, cos 2 alpha into alpha, cos 2 alpha into alpha. So right here cos 2 alpha cos alpha. Next, cos 2 alpha, next sin 2 alpha minus sin alpha. That means minus sin 2 alpha sin alpha. Right. Next one. Anyhow, your space is not enough. I will drop this part and I will write here. Okay. This gives us equation number 1 first. Now, what we need to do next? Next one here, cos 2 alpha sin alpha. So right here, sin alpha cos 2 alpha. Next, after this, what is there here? Sine 2 alpha cos alpha. So plus sine 2 alpha cos alpha. Next one, minus sine 2 alpha cos alpha minus 2 sine minus sine 2 alpha cos alpha minus sine alpha cos 2 alpha minus cos 2 alpha sine alpha. Next, after this, minus sine 2 alpha sine alpha minus sine 2 alpha sine alpha. Next, cos 2 alpha cos alpha. So that becomes as plus cos 2 alpha cos alpha. So here again two more formulas you have to remember, that is cos of A plus B is equal to cos A cos B minus sin A sin B. And the one, sin of A plus B is equal to sin A cos B plus cos A sin B. These two formulas you have to remember. Now check carefully. For first one, I'll apply this formula. Then cos of A plus B means 2 alpha plus alpha. So I'll write here cos of 2 alpha plus alpha. And next one here, sin of 2 alpha plus alpha. Here minus common, again same method, sin of 2 alpha plus alpha. Here again cos of 2 alpha plus alpha. So what do you get from this again? So I'll write this part here, remaining part I am completing this place. So now here's 2 alpha plus alpha, 3 alpha. So right here cos 3 alpha sin 3 alpha minus sin 3 alpha cos 3 alpha. This gives equation number 2. Now, one, you observe that if A square is there, you found it is everything 2 you got. If cube is there, you got as 3. Similarly, so I'll write here from 1 and 2. Similarly, A power n is equal to, you can write cos n alpha sin n alpha minus sin n alpha cos n alpha. So hence it is 2. So that is about your 15th problem. If you have any doubts, you can comment on YouTube comment section so that I can help you out. So may God bless you all.